Thank you for agreeing to meet with me again. Like you said, you wanted me to look into the issues we were having with our laser cutter and give you a little background, some suggested actions, and see how we can fix it. So as a background to the issue, in case you forgot, this is our Omtech K40 laser cutter that we use to create products such as our snowflakes that we sell online, along with other products such as customized cut sets, customized wood products that people want laser cut. And so on. And so to a background of the problem, some of our operators found recently that the laser cutter was giving different powers to each quadrant. So as you can see on this piece, ignore this middle stuff, on these rectangles here, in the top left it would cut good, and it would cut good in the other corners, but once you got into this bottom right corner, which is furthest away from the power source, it would not cut through. And so ideally, as a baseline data, it should cut through all the way like this piece. You can see these four rectangles, it cuts all the way through. And so the problem statement that we came up with was that because the power was different in all four quadrants, then it is most likely a problem with the mirrors being aligned. So as a reminder to how these work, if you look over here, we have a laser tube behind this wall here. That's the CO2 laser tube. That bounces the laser off of that mirror back in that hole, off of this mirror, and then off this mirror into this focal lens that's within this tube, down onto the material being cut on the laser bed. So this would be mirror 2 and mirror 3. These are the only mirrors that have ranges of motion. So as you can tell, this one has just one range of motion, and this one is the other range of motion. So to measure and test for success, we used these bullseye stickers, and then we would place them over the mirrors and do test spurts of energy into the sticker to test for precision. On these K40 laser cutters, the accuracy is not important, the precision is important. So upon all four quadrants, you want the four dots from each hole to be very, very close together. And so the way that we tested that and we measured for success is using a tape measure that we measured against other tape measures to ensure it was correct and verified that the distances were the same across all of them. And then we'd measure the distance between the holes, and we needed them to be within 1/16 of an inch for the laser cutter to perform properly. So the results, like I showed you before, I guess, they weren't cutting all the way through. After we did the fix, they were cutting all the way through on all four quadrants. As you can see here, I have an example of these bullseyes. So here we have before. On mirror 2, that was pretty good. But on mirror 3, you can see that there's a huge gap, especially between that one and the other three. So the first three quadrants were good, and the fourth quadrant was very far off. And this fourth quadrant was the quadrant that was not cutting correctly. And so that showed us a little bit more that our hypothesis was correct and that the mirrors were misaligned. So here are the proposed actions and what we feel like we need to do as a company to make sure that this is not to continue happening. So if you'll come look here, you can see on these mirrors, there are 3 screws. And on these 3 screws, there are nuts. We found upon first evaluation that one of these nuts was loose, which allows, while the thing is in motion, trying to make products, this allows the screw to move and it takes the mirror out of alignment. And so these screws need to be tightened at all times. And so our suggested action for what the company needs to do is to increase our maintenance on these machines and add part of the maintenance to be verifying that these nuts are all the way bolted down and then the mirrors are in alignment every time before use. Additionally, if that does not fix the problem, we need to start adding glue or some kind of adhesive to those bolts so that they do not become loose while it's working. So for the outcome, we found, here we are again, after we adjusted that mirror back into alignment, that's mirror 2 after we fixed it, and mirror 3 after we fixed it, You can see they are far more precise. And the laser cutter, again, over here, was able to function correctly, all four receiving equal power, which makes it so we're able to make more snowflakes without wasting so much product. Because this acrylic can be expensive, and our company doesn't want to waste so much of it. And we want to not waste our time. One of these sheets can take up to an hour to cut and engrave one set of snowflakes. And so it's very costly for operators to have to waste an entire sheet and do it again. So that is what we suggest needs to happen. That is what we found was the problem, and how we can fix it. We found in the future that adding maintenance or adding glue or adhesive to these so they are less likely to move would be a very cost-effective way to make sure that we don't lose productivity and costs in our laser cutter while making products for our customers. In conclusion, we were able to find the problem using different root cause analysis tools, such as the 5 whys, the Ishikawa diagram, and many more. And because of the root cause analysis, we found it was the mirrors that were causing the issue, and we found a solution to the issue and what we can do to make sure the issue does not happen anymore. Thanks.